Hi everybody. I wanted to give you a quick little video on even and odd functions, kind of intuitively in thinking about symmetry and graphs. Later we'll talk about how you figure it out from an equation, but we're just going to talk about symmetry and graphs this time. So I'm going to show you some examples of even functions, and I want you to think about, okay, what is similar about these graphs? So there's an even function. An example. There's another example. There's another example. There's one more. Now that one's just a bunch of dots, these blue dots. But there is something that's common to all of those. There's actually a couple things that are common, and I might change one of these because of that. Let me change this. Put that up there. Okay. So when you're looking at these, let me take some of them off so you can see one at a time. Okay, what are things that are true about that graph? Well, one thing that's true is red. But hopefully you're noticing that when we talk about symmetry, what are all these symmetric around? They are symmetric. And what are they all symmetric around? They're symmetric around the y-axis. And that's true for all even functions. Your function could be a bunch of dots, where if you look at the left side, we look at this side over here, it is a mirror image of this side over here. And that's it's as if we could put a mirror right there on the y-axis, which is why we say that that's symmetric then, over the y-axis. If we look at this one, if I put away those dots for a minute, yep, this goes down and up, this goes down and up, and they look like they are mirror images of each other across that y-axis. Same here, and same here. So all of those functions are symmetric about the y-axis. Okay, you could flip the picture on the right over to the left, and they'd be the same if you could flip them over the y-axis. Okay, all right, so that's even functions. Now let me turn those off for a second, close it up. Let's talk about odd. Okay, let me show you some examples of odd functions. There's one graph. There's another one. Are either of those symmetric about the y-axis this time? No. So they're symmetric about, they do have a weird symmetry about them, but it's not over the y-axis. See, if this was symmetric over the y-axis, this, what I would call maximum, otherwise known as the top of a hill, would be the same top of a hill over here, right? But that's not true. They're not symmetric about the y-axis, but they do have a symmetry about them. This does have a symmetry about it, but it's not over the y-axis. Can you figure out what it is over? I'll put all of them on there. What's true about these functions, and let me use, see, which one do I like? I'll use this one, that's easiest. There is a symmetry about this, and the short version is if you flip it twice. So we flip it over the y-axis, and then we flip it over the x-axis. So we take this 6, 2 point, okay, 6, 2, and we flip it over the y-axis, we would have negative 6, 2, right? We flip it over again, we'll have negative 6, negative 2. Okay? So this positive 6, 2 became negative 6, negative 2. Um, so that's one way to think about it. It's reflecting over the y and over the x, or over the x and then over the y. Either way, it won't matter. Another way to think about it is instead of it having a line of symmetry, it has a point of symmetry. And that point of symmetry is at the origin, the 0, 0 point that we call, the fancy name for that is origin. So these graphs all have a center point that they are symmetrical about, okay? And that center point is the origin. And that is what makes them, that's the visual hint that these are odd functions, okay? And we're just talking about the graphs and visual hints for now. We'll talk about why those are special later in their equation. But odd functions are symmetric about the origin, okay? So does everything have to be even or odd? No. There are a ton of functions that are neither odd nor function, kind of like there were series and sequences that were geometric or arithmetic, and then there were a whole bunch that were neither. Well, there's even and odd functions, and there's a whole bunch that are neither even nor odd. Here's an example of one. Now this one has a symmetry about it, but it's not the y-axis and it's not the origin, right? Let's look at this guy. This one has symmetry. It's not the y-axis though, and it's not the origin. The center point or the center line that is the reflection. This one doesn't even have symmetry, right? I mean, this one's got a small little dip here and then a bigger dip down here. Well, those dips are not the same. So it doesn't even have symmetry. All three of those fall into the category of neither even nor odd. Not even, not odd. Okay? So the bottom line here is even functions have symmetry about the y-axis. Odd functions have symmetry about the origin. And neither have neither. So let's look at these. Let's try these out and see if you can figure out if they're odd, even, or neither. I'll graph this one. I don't want to graph all of them at the same time, so let me calm these down a little bit. All right, so what do you think? Is this function symmetric about the y-axis? Is it symmetric about the origin, or neither? Yeah, it's neither. That is true. It's a neither. All right, let's look at this one. All right, is this one, and let me zoom in a little bit. Is it symmetric about the y-axis? Is it a reflection? Is this side perfectly reflected all the way across to this side? So if we look at this point here, it looks like it's at about 1, 3. Is negative 1, 3 the same? Is it on that graph? Sorry, I read that wrong. 1, 3. Okay, if I go over here to negative 1, 3, it's not even on that graph. So nope, that is not even. It's not even remotely symmetric about the y-axis. Sorry, about the origin. So that's neither as well. Neither, 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 neither. So this one was neither. This one is also neither. Both neithers. Okay, let me get rid of those for a second. Let's look at this guy. All right, is it symmetric about the y-axis? Is the stuff on the right negative 0.8161998 exactly the same except the x's change? Whoop, I just saw it. Looks kind of like it might be. Oh, negative 1, 3. And 1, 3 is on there. So yep, it is symmetric about the y-axis. So that one would be an even function. Okay, these were odd. Sorry, That was neither. My bad. How do you spell neither? I can't do it all of a sudden. And let's look at this one. All right, if this was symmetric about the y-axis, this little top of a hill would be over here at this little top of a hill, but it's not. So it's not even. Then we have to figure out, is it odd? Does this look like it's reflected kind of diagonally? Another way to think about it is if it's reflected over the y equals x line, but that's another story. Let me see if I can show you what I mean by that. Oh, that's not true. My bad. I'll have to erase that. All right. What do you guys think? This one is odd. Okay, so I'm going to take these little names off real quick so we can go back and you can use these. I'm going to attach them to this video or somehow make them available for you to play around with, these examples of why they're odd, even, or neither. And see if you can play around with them, and hopefully this is helpful. Please feel free to contact me, remind, Schoology message, or it's a little bit slower, but you can still contact me by email. Anytime you're stuck or you're like, nope, I just would like her to teach me instead of a video. Okay? All right. Later.